Here's something 90% of chem students don't get when it comes to Pauli's exclusion principle. Pauli states that there can only be 2 electrons in an orbital. This is wrong. It's what it implies, but it isn't what Pauli actually says. Let's unpack this. Pauli said that no 2 identical fermions will have the same set of quantum numbers. This sounds super complex, but let's pick this apart. What the hell are fermions? Electrons belong to a family of particles called fermions. Easy. So already we've made this a lot simpler. So what are quantum numbers? What I'm going to do is use an analogy and circle back to the chemistry. It's basically the electron's ID number. Just like you've got ID numbers at school. Let's say, for example, say your ID has 4 numbers which can be used to uniquely identify you. So the first one tells you which grade you're in. Let's say year 11. The second one tells you which class you're in. Let's just say class A. The third one tells you which desk you sit in. Let's say the front left corner. And now the last one tells you which seat you sit in. Let's say the right seat. I'm going to ask you a question. So let's set the scene. The desk had 2 seats and you can sit either on the left or the right seat. So if no 2 students can sit on top of each other in class, because that would be weird, how many students can sit at each desk? That's right, 2 kids. I think you see where I'm going with this. So let's circle back to the chemistry now. Let's take this electron in argon. So N being the shell number, kind of like identifying the year. This one tells you which subshell it's in, kind of like picking the class. And this one tells you which orbital it's in, kind of like picking the desk. Now finally, this one, the spin number, tells you what its spin value is, which is kind of like picking the seat. Now what's unique to electrons is that they only have 2 possible spin value, half or minus half. So think about this. The electrons that go in an orbital can only have 2 possible spin values. And remember, no 2 electrons can have the same ID number. So how many electrons can go in an orbital? 2. So now you see, Pauli just said the stuff about the ID number, and the 2 electron thing is what's so significant about it. So if you need to talk about Pauli's exclusion principle in an exam, define what he actually said first, then link it to the idea that only 2 electrons can go in an orbital.